Hello and welcome to Kickback Science Podcast. I'm your host, Dr. Luke. This podcast is your place to get the tools and knowledge necessary to navigate the world of health and wellness. So kick back and let's talk science. This is good content. This stuff has gone crazy. We'll jump into it. Let's dive in. Let's do a little science. I'm going nitty-gritty science right now.
I've been looking forward to this.
Kind of going on a little bit of a tangent.
Oh, yeah, that's right. I forgot about that.
The information we discuss in this podcast is not meant to be taken as medical advice. It is simply informative. We're not affiliated with any organization or institution, just a few guys talking science and having fun.
Oh, gosh.
Oh my god.
Hey, boys.
What's up, guys?
Good morning.
I missed you guys.
Yeah.
It's been 3 weeks.
Yeah.
And it's also been 3 weeks since I worked out.
Oh.
Yeah.
Oh.
Bad back stuff, you know. Then I went skiing.
Yeah, you're going to follow one of the Kickback Science workout programs. Get your back in shape. Get your back in shape.
Getting back into it.
Gonna be bringing sexy back.
Hell yeah. I'm excited.
I'm
looking
excited to
forward
see.
Yeah,
Luke
I'm
seems
excited.
pretty confident. He can get me where I want to be. I got a wedding July 4th weekend. So I got
It's
time.
big, yeah.
Somebody's getting married on July 4th weekend.
Yeah. I'll have to just bring fireworks to
Yeah,
the
that's
wedding.
you're a firework guy, dude.
You know, a big firework guy. I love lighting off fireworks.
Explosions.
But yeah, it's gonna be a solid summer. A lot of things going on. But anyway, what are we talking about today about?
All right, welcome back, everybody. I'm your co-host, Reed, followed by Joe, the
Yeah,
other
dude.
co-host right there,
Yeah, dude.
and then with Dr. Luke. How you doing?
What's up, boys? I'm good. I
I'm
missed
excited
you
for
guys.
this one, dude. We got a good one today. This is something I've been doing for 10 plus years. Either you've done this before?
I've done a little bit of it.
Yep, I've dabbled quite a bit.
You've dabbled.
I
quite a bit in
forgot
this?
that both of you guys were doing this.
Yeah,
too.
I've been doing.
You were
Amy's
talking about
doing
that
it
one
too.
in the
My
calorie
brother did
restriction
it.
I
one.
just got off it though recently. Trying to.
We'll see if you stick to it after we talk about it a little bit more.
So we got another diet series showdown today. This is part 2. We're going to be exploring fasting and time-restricted eating. So that's what I've been doing for the last 10 years. I'm excited to see what Dr. Luke has
You've
to
been doing
say
that for
about
10 years.
10 years plus.
What is
It's
your
a
like?
long
What
friggin'
is your
time.
protocol? What do you follow?
I just do 8 hours of eating. So
and
like,
when is it
from, like-
consistent times?
Yeah, it's like 12:30 to 8:30 at night. But
Dang.
usually I stop.
You
at
don't eat till 12:30?
No, I just don't. I'm not hungry in the morning.
When I was doing it, I guess it was 11 o'clock
11 o'clock
to 7. Yeah. And
Yeah, I messed around with 10 to 6 and then 11 to 7 as well.
Yeah, it's
And
kinda
at first, I
finding
mean,
what
it
works
was
for
like
you.
it takes a while for you to adapt, but
dude, when
You
I
do
first
adjust.
started doing it, I was very angry in the mornings.
yeah, it is
It
hard.
takes a little bit of time to get used
Oh,
to, but
God, it was
then
tough.
it becomes normal.
Yeah. I do like eating in the morning a lot more though, because I like food. So
Yeah.
Gotta get that protein in too, right?
yeah, gotta get that protein in.
That's and we'll talk about like why that is a concern about these diets. But so when we're talking fasting and time restricted feeding or time restricted eating, the approach to these is similar. That's why we're grouping them together, but they are different. So when you say fasting, what we're referring to when we're talking about this and what you will read in the literature is fasting is indicative of a 24-hour plus break from feeding. So you're fasting for over a day, or for 1 day or more than 1 day.
No, thank you.
Yeah. Versus time restricted eating or time restricted feeding. I'm going to use those terms interchangeably. You'll see in animal research versus human research, like animal research, you'll see time restricted feeding. Human research, you'll see time restricted eating. It's referring to the same thing. And I'm going to use those interchangeably, but what those are, or what time restricted eating is, it's different than fasting in terms of you're restricting your feeding window to a certain time during the day. So, I mean, as we were talking about, Reed, you're doing 12:30 to 8:30, and Joe, you said you did 11 to 7. So that is your feeding window. And you'll hear that referred to as a 16-8 time restricted eating
And you're
model.
still trying to get the same amount of calories as a full day of eating, but just in that smaller window?
Well, we'll talk about that, like the calorie intake and how that kind of changes things a little bit. But the 16-8 model tends to be the most common, and there's a reason for that. And it means like 16 hours of the day you are fasted, 8 hours of the day you are taking in nutrients. And this came from some really cool animal studies that have been done. So Sachin Panda, he's at the Salk Institute in California. He's kind of pioneered this circadian aspect of food. And what that means is your body has what's called a circadian rhythm that we think about as our sleep-wake cycle. And when you look further into circadian biology, you actually see that so many cells within our body function differently at different times a day. Even your blood pressure, your heart rate's different. Your immune system responds differently to viruses and bacteria depending on the time of day. So you could be exposed to some sort of virus in the morning versus afternoon, and your immune system's ability to adapt is actually going to be different. Wow. So immune cells have this circadian aspect. Yeah. Essentially, like, so much of our physiology is regulated by circadian rhythms. And it all comes down to these, what are called clock genes. And there's a variety of these, but some big ones are period, cryptochrome, BMAL, and there's others, and clock. There's actually a gene called clock. But what these genes, they kind of work together through this, what's called a negative feedback loop, where an increase in some will cause a decrease in others. And they're able to cycle and fluctuate throughout the day. And they play a role in regulating how, awake you feel, how tired you feel, how metabolically active you are, how much, even in cognition, how much attention are you paying to things, how much energy do you have? And that's why at different times of the day, you feel very differently. Like in the morning, we're ramping up our metabolic rate. We're increasing body temperature. We tend to be more alert and attentive. I mean, not right when you get out of bed. If you're waking up to an alarm clock and you're still half asleep, that's different than like as you play out the next hour of your day, you start changing metabolically. And that is all regulated by our circadian rhythm. And we used to kind of just think of circadian rhythm as being just governed by sleep-wake cycles.
Can you go over circadian rhythm for people that don't know exactly what it is? Because I know you are the master. You just did your dissertation on it. So can you just give everybody, our listeners, like a little example of what that is? Just a quick blurb before we keep going with this.
Yeah, so circadian rhythm is, kind of what I was just describing of like this process of your body's physiological function that changes throughout the day, and it regulates three key things. One being sleep-wake cycles, one being feed and fasting cycles, and the other being activity and rest cycles. It's very important for your body to have consistent circadian rhythms. And when you can kind of understand the importance of this when you think of like jet lag, for example. If you fly, East Coast to West Coast, and your circadian clock has now been totally changed, it's just 3 hours, but you notice the difference. Like physiologically, it takes your body a while to understand that you're on this new sleep cycle.
Even an hour does. Like going from Minnesota to Colorado, that hour change is just enough because like you're going to bed, but it's like the wrong time, or you're waking up at like it's 5:30 in Minnesota, but it's 4:30 in Colorado. You're like,
yeah. And I mean, this is
I'm up extra early today.
Exactly. And I mean, this is actually showcased pretty well in the research. You actually see that professional sports teams statistically tend to perform worse when they're traveling across these time zones. And this gets into, there's a circadian aspect of training where, you want to practice and have and shift your body's metabolic cycle and activity cycle to resemble when you want to optimally perform. And you look at athletes, and I mean,
they're doing a podcast on circadian rhythm.
Yeah. Well, it is really important. It is really important. And going on a little bit of a tangent, but so the
Sorry, I threw you out there. You're
Yeah.
talking about sports.
No.
You're talking
You
about
can never
sports.
throw me off my game in
Yeah,
circadian
yeah.
rhythm. I love this stuff.
Science.
My PhD, I was like drowning in circadian research. It's so awesome. But so when you look at athletes, I mean, their professional athletes are playing these games late into the evening, and so that we can sit on our couch and watch them and cheer them on. And the problem with that is when they want to be, at this optimum level of performance, this high level of alertness. So they have to shift their circadian rhythm. And imagine like playing for 3 hours at this high intensity, and over time your circadian rhythm is going to shift. I mean, these athletes aren't going to sleep till 3 or 4 in the morning. Their circadian cycles are completely disrupted. And so that's how it relates to performance. But you notice this stuff with jet lag when you travel, like especially like international travel, where you start to feel worse right away. Your body's just confused and trying to figure it out. All of this is because of how important it is for your body to have this consistent, it's called an oscillatory rhythm of these genes and functions. They'll go up and down throughout the day. They regulate every aspect of your body.
So, speaking of this, with athletes, since we're talking about athletes, and what we're talking about today, the restricted feeding, can that combat the circadian rhythm in a positive way?
Yeah. So, and that's really what we're going to get into, and like the science and like those questions like that are what led into this research, because it started with, okay, we know if you go to bed and wake up at the same time, if you can get a consistent sleep cycle, your function during the day is going to improve multifold. I mean, you're going to feel better 10 times out of 10 because you can get your body into this steady circadian rhythm. So sleep consistency is so huge. And so, but we know sleep isn't the only thing that regulates circadian rhythm. Activity and feeding does as well. So a lot of research went into, okay, what if we time our feeding window to act just like sleep? What if we just eat during this 8-hour window? Kind of like we just sleep during this window. Then our body knows exactly when to be metabolically active throughout the day, and it knows exactly when to do the opposite, to fast and to start to store energy versus break down energy. Is that going to improve circadian rhythm, which you would then see actually an improvement in your sleep-wake cycle and activity and rest cycle? And when this research kind of took off, it was from a paper out of Sachin Panda's lab down at the Salk Institute with mice. And this was back in 2012, where essentially they took mice and had them eat ad libitum, which you see in the research when you see ad lib feeding. It means they can just eat whenever they want, versus an 8-hour feeding window where they only had access to their food for 8 hours. And they found pretty incredible results that were replicated over the years with mice. So they see increased metabolic health, increased liver health, cardiovascular function, body fat loss. These mice were getting protected from obesity, diabetes, and all these related diseases. And it just from an 8-hour feeding window. A funny story about the 8-hour feeding window is actually not picked for a certain reason. It wasn't meant to mimic sleep. It was because the graduate student at the Salk Institute, his girlfriend, not to out her or anything, but his girlfriend actually did not want him in the lab for these long periods of time. And so having, like these studies go on for longer or shorter than 8 hours, like it was because she didn't want him in the lab. And this resonates with me a little bit because during my PhD, I did these studies where I took groups of mice and I did a 12-12 feeding window. Essentially, I just had them feeding only during their typical active cycle, which their mice are nocturnal, so they're very active at night. And so I had to go into the lab and take the food away and put the food back on every 12 hours. And so twice a day, I had to go into the lab and then would measure the food and how much they ate and try to assess these levels of circadian rhythm. And that was such a pain in the ass. I mean, I had a lot of help. Shout out Nick, shout out Travis and others who helped. And because you you have to spend so much time. It's hard to do these studies. That's the bummer. But I mean, back to the research, you do see these benefits play out. And what's interesting is some of the studies show independently of calorie restriction, these benefits are happening. And that's the really, really important thing to take away from this is, you're talking about an independent effect of just a feeding window. And that would indicate that there is this circadian aspect to it. But the problem is when you get into the human research, it does not shape out this way. It's crazy.
Okay.
You see the research done with human studies, and it's really positive. People going on time-restricted eating protocols tend to have better health outcomes. But you look further into the data, and it's because of this calorie restriction that they're actually on. And so when you go on a feeding window...
What kind of calorie restriction are we talking?
So some studies were over 500 calories per day. And I'll talk about it. I'll talk about a few different studies and the feeding windows and what exactly they found and such. But kind of this overarching issue with the time restricted feeding is we still haven't been able to demonstrate that there is this independent effect in humans. But it's so perfect in mice. And another problem with the animal research, though, and a reason that it doesn't really resemble human metabolic function is because mice, like when you fast them for 16 hours, it resembles multiple days of fasting for us. And because mice have, it's kind of like around a 1-to-4 ratio, where 1 day of fasting for mice is 4, if not even more days of fasting for us. And so...
Wait, you mean the other way around? 1 day for a human is 4 for a mouse?
Yes. Yeah, did I say that back?
Yeah.
I always say these things backwards. I'm glad you're following along to correct me. Essentially, mice are, much more metabolically active, and they actually will die from taking their food away. They're smaller, and they actually, it's interesting, they grow throughout their entire lives. They continuously grow, whereas we stop right around age 25 and such. But mice, it's a lot harder on them. A 16-day fast does not resemble, or a 16-hour fast does not resemble a 16-hour fast for us. Okay. So the research doesn't translate as much. When you do a 16-hour fast in mice, you're actually looking more at this intermittent fasting protocol because it would resemble like multiple days of fasting. Right. And so getting into the research, you have to think about, are calories controlled? Because we were just talking about in part 1 about calorie restriction.
Sorry, I keep cutting you off, but with mice, you are giving them the same thing daily, correct? The same exact food daily.
Yeah.
So there's no fluctuation in that, whereas what you're probably about to get into, humans.
And what were they eating? What were you feeding them?
So it's just typical mice chow.
Chow, okay.
And it's... I don't know what our lab actually, like the composition of these. So I don't know that off the top of my head, but yeah, I mean, it wasn't.
But it's like a well-balanced diet for them. That's kind of what they need. Okay.
Yeah, we didn't like change anything with diet.
You didn't give them like Burger King, McDonald's.
No, see, that would be an interesting study though too. Is like give them a couple Big Macs and see like does this change it?
Control group.
All of a sudden, you have those New York-sized rats in your cage. You're like, what happened? Holy crap.
Gave him some Big Macs. Now, I don't want to spend a ton of time talking about the time-restricted feeding research that shows calorie restriction. I mean, there's some pretty good meta-analyses, which again are a study of studies. It's essentially taken a bunch of different research and putting it together and compiling what we know. They tend to be very detailed and descriptive in terms of the outcomes. And Matt Chamberlain, he's over at the University of Washington. He leads this aging lab over there. He put out a really cool meta-analysis. This was back in 2021, essentially like a position stand on fasting versus intermittent fasting versus time restricted feeding, where are we at with the research, and really highlighted all the human studies that show benefit and how many of them are because of calorie restriction when you look further into the data. So I don't want to spend a ton of time on that because we've already talked about calorie restriction.
Yeah.
But there are some studies. So in order to answer this question, we have to look into if calories are equated or if they're what are called eucaloric, and making sure that their calories are consistent between the two groups. And then you can also compare if they're both calorie restricted. So if you have calorie restricted versus calorie restriction and time restricted feeding, we can compare those studies as well. But I don't want to spend time comparing time restricted feeding versus controls if they didn't control for
It seems
calories.
like that is always the issue with human research, is that outside little guy saying, hey, come eat this. I know you're on this little study, but you really like this Snickers bar, so
I love that you're catching on to this like thing with nutrition research. That's why it is.
yeah.
But the problem is the media finds the studies. They know that people love learning about nutrition, and media will find these studies and just make this crazy highlight of time restricted feeding is
Right.
cure to cancer. And I always give that analogy because you see those types of claims. But yeah, exactly what you're saying, Joe. And I think you're going to realize this as we go through the research, because that's really the nutrition research is just all over the place. It's really hard to control, though. It has nothing to do with the researchers that are conducting these studies.
It's the cravings that people have.
Well, it's not even that. It's just there's so much discipline. Well, yeah, I guess it is cravings, but like there's so much discipline that goes into following a diet, and humans are the worst participants. They just don't tend to follow strict dieting protocols.
There's
And
just so many outside aspects that affect a life.
what we call confounding variables that contribute. But let's dive into the research here on calorie equated studies comparing time restricted feeding. So one paper that was just done actually in Australia, mate. What they did is, this was a really well controlled study. They equated for not only calories but also protein. So they made sure they were having 1 gram per kilogram of protein. And that's important because when you shorten your feeding windows, you're fasted for so much longer. And if you haven't tuned into the protein episode, we talk a lot about why that actually is probably not beneficial for you. Because if you're fasting and time restricted feeding, it's very likely that you are going to have a hard time meeting required protein intake. But the researchers in this study, they did equate between the groups. And so what they did is they provided the meals to these individuals too. So it's like that tends to control the studies a lot better, because if you get food brought to you, you're going to eat it, and then you don't have like this like you're going out and eating more than you should be in the studies. But it was only done in 10 days, for 10 days, but it's really hard to do these studies again when it's highly controlled like this. And they had 18 different individuals, divided them up into groups, and they had a time restricted feeding group, which ate from 10 a.m. to 6 p.m. So that's your 10 to 6, 16-8 feeding window. And then the control group turns out actually ate for a 12-hour window versus the 8-hour window. They only had a change in feeding from 8 to 8. So it's 10 to 6 in the time restricted feeding, and then 8 to 8.
Normal.
It is normal, but it's still kind of this time restricted feeding in a way. But they found no differences in muscle protein synthesis. So that's important. Eating during this 8-hour feeding window, they were getting 1 gram per kilogram. They were still able to meet this protein synthesis.
Can you explain protein synthesis, please?
Yeah. So protein synthesis, it occurs during this anabolic phase. When we talked about the like muscle building during our protein episode, your muscle has to go through protein synthesis, which synthesizing new proteins, it's building, and you want your body to be capable of building, whether it's, proteins that circulate around in your body or regenerating tissue and organs. So having a increase in protein synthesis is a good thing.
It's important.
Right. And the problem is when you're restricted in protein, you don't meet this optimum level of protein synthesis, and you get into what's called a catabolic stage where you're actually breaking down proteins.
So does that window shorten then with intermittent fasting? With
yeah, well, in this paper particularly, it didn't make a difference on protein synthesis when they had an 8-hour feeding window.
Gotcha.
But they didn't really find many differences in other aspects of the study. But the problem is they only shortened the feeding window by 2 hours on each side. It was 12 hours versus 8 hours, as opposed to like eating whenever you want.
Yeah.
But still, it showed 8-hour feeding window was able to preserve protein synthesis, which we need to know that. It's important. And then you look into another randomized clinical trial at the UAB hospital where there were 90 obese participants that were already going through a calorically restricted diet. It was a weight loss protocol that they were doing at the hospital, and I believe it was around 30% calorie restriction that they were already doing with these individuals. And so here we're going to talk about a study that has calorie restriction group as the control, and then they compare it with a time-restricted feeding, also calorically restricted group. Because, again, you compare time-restricted feeding against controls, and you don't equate for calories. It doesn't answer the question. But this one equated for calories by having them calorically restricted in the control group itself. And they randomized them to either an early time-restricted feeding group, so the 8-hour feeding window was between 7 a.m. and 3 p.m., versus just caloric restriction where they ate whenever they wanted. And they found that the time-restricted feeding group did lose more weight, but there was no difference in fat loss here. And when you look at the data, they controlled for these things, but it's hard to address what they're actually eating, because there was actually a 214 calorie per day deficit in the time-restricted feeding diet still. So yes, I mean, it's closer than this 500 calorie difference, but they're still calorically restricted. So benefits you see are still tied to this calorie restriction. And then another randomized controlled trial, and then I can stop talking science for a second. So this one, I just wanted to pull up the most recent data on attempts to control for calorie restriction. What they did, this paper came out of Chicago in 2020. They had a randomized controlled trial for 8 weeks, and they actually looked at different feeding windows. So not just this 8-hour feeding window, where they had a 4-hour feeding window from 3 to 7 p.m. and a 6-hour feeding window from 1 to 7 p.m.
Those are
versus
like
control.
That's extreme.
Right?
Yeah. So, but people do this, and we'll talk about,
how big
people
of a
eating
meal?
one meal a day.
A 2,000
Just gotta be chowing down
calorie
for those
meal
4 to
with
6
all
hours.
of your nutrients in one meal. I mean,
Yep.
I would not be able to function at all. No way.
There's the OMAD diet, or 1 meal a day, where people just eat one time per day. And like some people just gorge themselves and try to get like 3,000 calories in one meal. That is a thing. And here they were looking at the 4-hour versus 6-hour feeding window. And they did find benefits in fat loss and circulating levels of insulin, but there were no differences in glucose, blood pressure, cholesterol. But they had a reduction in 550 calories per day versus the control group that was eating whatever they wanted. And then you look into these shorter feeding windows like this. So the 6-hour and the 4-hour, that's a huge calorie deficit. And the impact that is likely having on your body's ability to go through protein synthesis to build muscle, you're going to see a decline in lean mass, which is your muscle, if you are not making sure you hit this protein intake. And even if you do, I'm not convinced, based on the research, that you're still not getting into this catabolic state or breaking down muscle when you restrict this feeding window so much. right now, based on the data, it seems to be that an 8-hour feeding window, you can still preserve lean body mass. And there is a paper where they combined an 8-hour feeding window with resistance training, finding that it even further improved your ability to grow muscle and to sustain
Is
muscle.
there such
That's
a
what I
thing
do.
as a split 8-hour feeding window, like a four, and a 4?
That's a good question.
Like you
Yeah.
have 6 to 10, and then you have to take a 4-hour. I guess that'd be kind of
So that
same.
is actually more of an approach just to hit calorie restriction, because the reason that people tend to do these 16-8 diets is they're under the impression that during a fasting period, your body is getting some sort of physiological benefit.
right.
And so when you do a 4-hour feeding window, take a 2-hour break and do another 4-hour, that 2-hour period of time is not going to do anything
okay,
fasting wise. But it's a good approach for calorie restriction. And that's really, again, what all this comes down to. When you go on these 8-hour feeding windows, that's an easy way for you to restrict calories. You don't have to think as much about how much you're eating and what you're eating. All you got to do is set these times. But now, when you look at the data, though, it doesn't seem like it's providing this independent, physiological benefit to us other than calorie restriction. That seems pretty clear. The circadian data is not as evident as with the animal research. And circadian gene influence, if that's your goal, calorie restriction and exercise themselves have independent influences on circadian gene expression. And so I'm not convinced that time restricted eating is having a benefit for people other than calorie restriction.
I mean, makes sense. Shorter window, less
Yeah.
time to eat, but
And you can stay more disciplined.
but you can also.
That's kind of what I see.
I think you probably you do the window,
Yeah, I do the
but
window.
you get. Are you in a deficit, or you get all of what you need in a day?
I would probably say I'm in deficit because
Yeah.
I'm missing those calories in the morning, and then, yeah. But now I've changed it up. Now I'm doing more protein, kind of after our protein talk. But
Yeah.
I'm in a deficit for sure.
Okay.
Yeah, and that's what seems to be. And before we move into fasting, I forgot there was a recent meta-analysis that just came out a few months ago that actually got a little further. And some people might have questions about, like, if you're going to do time restricted feeding, is it better to do a early versus late feeding window? Should I do 7 a.m. to 3 p.m. Versus 10 to 6, whatever it might be. And this paper, they looked. It was a meta-analysis, so again, it grouped all the research we have on time restricted eating and health outcomes. And they split them into studies that had an early feeding window. So this was a feeding window before 11 a.m. versus studies that had a late feeding window, which was after 11 a.m. And then they had an intermediate group as well, which didn't define or didn't have the feeding window consistent. They were just more concerned about the amount of time. So early versus late. And they found that there was no difference between if you started earlier versus if you started later. And this paper, they tried to make it as like, it helps you lose weight versus a control group, because they looked at versus control. But not all the papers that they included controlled for calorie restriction. And it made no difference in terms of cholesterol, triglycerides, blood pressure, fasting glucose levels versus just a controlled diet. So these things weren't improved by time restricted feeding. And then there doesn't seem to be this difference. There's also a study that had people do early morning feeding. They favored feeding early versus feeding later, but had the same amount of calories, and looked at energy expenditure, because there seems to be this idea of, if I eat earlier on, I'm going to lose more weight. It's going to improve my daily energy expenditure versus people that eat later. They also found no difference in energy expenditure.
Taking into account activity levels, like people that work out and stuff like that?
Yeah, so this particular study was really highly controlled in activity level and calorie intake. It was a shorter study as well, but they, again, when you have these highly controlled studies, it's hard to run them for a very long period of time. But they did find that there wasn't a difference. There was let me pull up the paper real fast.
Because you always hear people say, like, breakfast is the most important meal of the day. So I was like, I'm missing out on that most important meal. But my best window is at 12:30 to 8:30. That just works best for me.
Your body's used to it now.
It's just so used to it, yeah.
But like in the beginning, I'm sure you weren't used to it, and you're like, I
was
miss
so hangry,
breakfast.
yeah.
Dude.
Yeah,
I would
I
love to
still-
have an egg.
I still do like.
Didn't you just recently start doing the feeding window again?
No, actually, so when I was doing my PhD and really getting into the animal research here, I was convinced. I mean, this circadian biology stuff is amazing.
You told me about it.
Yeah, I mean,
told me about it.
Yeah, and I mean, that's
And
why I decided to do the study.
I mean, it worked. I lost 60 pounds when I started, but calorie restriction. There's no way.
And
no
I
way
thought
was
of it
gonna eat
as
enough
like
food.
an
I think I was
independent.
down to like 1,500 to 1,800 calories a day.
Yeah.
And I'm an electrician, so I'm constantly active all day long. Then I would also go to the gym every day. So I must have been burning all my food.
Yeah, I would have been curious like to see
Dude.
what kind of energy deficit you were in.
I mean, 60 pounds is a lot.
That is a ton. That's wow.
It was a grind, and like we were just saying, I was hangry, dude.
Dude, it's bad.
Yeah, I don't remember how much weight. I know I did lose weight too, but I wasn't counting calories at that time because again, I was convinced there's a circadian effect. I mean, my PhD dissertation, I was measuring circadian gene expression with.
When was it that you figured out that mice versus human time restriction was not equated to the same level? You know what I mean?
Yeah, as I was writing my dissertation and
Like towards the end of it.
reviewing the research a
And
little
then
bit
you
more.
were like, oh,
Yeah.
no.
But I ended up not doing my actual PhD dissertation using the animal model of time-restricted feeding. I did it in human participants with exercise, which is a separate topic. But now to get back into this study of feeding windows, should it be earlier versus later, and are you missing out if you don't eat earlier? I still caution people about that overnight fast and continuing to be in this catabolic state in the morning. You know, you want to protect muscle mass as much as you possibly can. And so I'm curious to see as the research continues to play out if early morning feeding, you know, if we do uncover a little bit more about the benefits there. But right now where we're at, it doesn't seem to be that there's a difference. And so pulling back up the data, they did 45, 35, 20 in one group, meaning 45% of calorie intake in the morning, 35 for lunch, 20 for dinner. And then the opposite of 20 for breakfast, 35 for lunch, and 45 for dinner. So they just shifted most calories to be earlier or later. And they equated everything. And it was, there was no difference in energy expenditure. The morning group did say they were more full throughout the day, so it was easier for them. But the problem is they measured satiety. They even measured leptin and ghrelin. These hormones are actually what regulate your body's hunger and feeling of fullness. And the problem is they measured these things early. And so it's, you know, you're going to find that in the earlier feeding group, earlier in the day, they're going to feel more full. That makes sense. But yeah, there doesn't seem to be this difference. Again, in the animal research, there does. That's where this came from.
Right.
Early morning feeding windows make a difference.
All right, can we talk about risks now of going intermittent fasting? I didn't think there were any risks, but then all of a sudden this news article popped in my feed on Instagram. It was from people saying that intermittent fasting is linked to a significantly higher risk of heart disease, which I don't believe, which I don't see how that is, but it looked like they studied over 20,000 adults, and there was an increased risk from the people that the restricted 8-hour to the people that eat 12 to 16.
Yeah. So this is that prime example of media. Like it just like it works every time. Media just gets everybody. Now we're not talking intermittent fasting. We still got to get into that topic too. So that is still related to time restricted feeding. And yeah, I've seen this all over too. Like new study finds intermittent fasting increases cardiovascular mortality, 91%. The problem, so this study has not been published. This was a presentation at the American Heart Association conference. And so unfortunately, I don't have access to the study, and nor does the media who's writing this article. It hasn't been reviewed. It hasn't been published yet. We'll see when those data come out. But essentially what they did, they reviewed the NHANES data, which NHANES is the National Health and Nutrition Examination Survey data, where they've followed people from 2003 to like 2018, I think it spanned, and had frequent follow-ups and measured nutritional survey data with these individuals and then health outcomes. Are you laughing?
Yeah, it just sounds like they just were like, hey, how you doing? Come on in.
No,
I had a really tough weekend, drank a shitload, ate like shit, had Domino's, had Taco Bell. But it's all good. I'm still intermittent fasting.
It was more extensive than that. We actually get a lot of nutrition research from the NHANES data. It is, like Reed, you mentioned 20,000 participants. There's so much data to analyze here. But yeah, I mean, when you're looking at these like food recall questionnaires that they use, I mean, those are valuable in certain ways, but they're also a little sketchy in terms of having people recall their diets. And what they essentially found is that groups that were in this 8-hour feeding window versus people who ate whenever had this increased incidence of cardiovascular risk. And now the problem, again, we don't know how they analyze the data, don't know what they controlled for. Did they control for things like body composition or other disease risks or, and there's also this issue of what's called reverse causality, where people who already have cardiovascular risk may eat a little bit worse and, not focus on what they're eating. And there's papers that actually show people eating in an 8-hour feeding window have increases in BMI. BMI is a tough metric, but people tend to, if you don't focus on what you're eating, you can pig out in that 8-hour feeding window. That could have happened here. We don't know. And there's also studies that, like a recent study that shows that time-restricted feeding reduces these risks. So again, this is media, just being media, and it's...
So I just have a quick question. You said BMI, which is body mass index. Can you just break that down?
Yeah, so BMI is a metric that all it considers is your weight and height. So it's your weight in kilograms divided by your height in meters squared. And it's just essentially people who have higher BMIs, so tend to have larger body weights relative to their height, it's been correlated with a variety of chronic disease outcomes, especially obesity and cardiovascular disease and cancer. So it's useful, and that's why it's in the clinic. But the problem with BMI is it does not address health risks of two populations. One being people who are, have a lot of muscle mass. So they have much higher BMIs, but they are much, much healthier. And this is like people like bodybuilders or athletes that have a lot of muscle. And then it also doesn't address an elderly population that has lost muscle mass. It actually makes us think that they are healthier than they really are. And so it's a horrible metric in terms of you can get a lot more data from figuring out somebody's body composition, which tells you how much muscle and how much fat they have. But sorry, another tangent there.
I just want to
got to bring me back. We got to talk about fasting.
Hey, let's get back to fasting.
Let's just dive in deep, huh?
Okay. So fasting, I mean, it all kind of relates. So I'm not going to say this is going to be quicker because it never turns out that way. So fasting. Now we're talking about alternate day meal intake, or, having like one meal per day.
12-12 almost.
No.
12-01.
So it'd be like a 1-23. So like literally you're trying to take 24 hours plus between eating.
Oh, we talked about that very shortly.
Okay. Yeah, at the beginning.
Yeah.
And so that's what intermittent fasting is. You'll see people, like some people will try like a 7-day water only fast once a year, once a quarter of a year, or a 3-day fast. You'll hear, now that you understand what this is, you're going to hear about this more.
I thought that time restrictive was intermittent fasting.
So they tie into each other in a way, like when people say
I
fasting,
was confused.
I always get it mixed up too.
yeah, there's a fasting period when you're
Okay.
time restricted feeding. And
So-
so that's why we group these together, because they are very similar, but they're different enough to where I want to discuss them separately.
Okay.
And so fasting, again, when I'm talking about the research here, I'm talking about when you're doing these alternate day fasts or the 3-day fast or the 7-day water only
7-day,
fast. You hear about that all the time. And it comes from this underlying thought that there is some sort of biological process that is benefiting us during a fasted state. So you have a reduction in glucose levels circulating, which again, when you take in carbohydrates, gets absorbed as glucose. Having high blood glucose is what leads to all these metabolic issues down the line. So your body has to increase all this insulin to dispose of that glucose. Insulin's kind of like the chaperone that carries the glucose around and will knock on the door of a muscle cell or liver or fat and say, hey, yo, we don't want this glucose roaming the streets. You better take care of it. So insulin's got to go out there and take care of all this glucose.
Mm-hmm.
And having high insulin, high glucose, it leads to all these issues. And so one of the things that fasting does is it brings those levels down. So insulin is this energy storage process. And it doesn't allow for certain things like you hear about autophagy a lot with fasting. People bring up this physiological process that our body has called our autophagy, which is almost like you could think of it as a garbage disposal, street sweeper kind of mechanism that your body has to recycle degraded proteins, damaged organelles, and make sure that we don't have these cells that are degraded, and you get what are called senescent cells that kind of just hang out and release all these inflammatory cytokines, and they don't really serve a purpose. And it's because they've divided so many times and they don't function properly. And autophagy is a process where your body can go in and be like, hey, you should not even be alive right now. And it'll induce what's called apoptosis. So like making the cells like death mechanism essentially. And that's among a separate process.
Like
but
a protective state.
yeah, so your cells can actually only divide a certain amount of times, and then they automatically die. It's like this like cellular suicide. Like they know, okay, I'm kind of at this about 30 to 40 times in most cells. Some cells are different. But eventually it'll be like, okay, most of my processes inside are starting to become impaired. I better go through this cellular suicide so that the body doesn't, have to deal with all these damaged processes. Are you with me on that?
Yeah, I think so.
Okay.
Like,
I don't want to go too far into the weeds.
I think what you're saying is you stop. You're trying to protect the internal organs in a way, right? So the outside cells are like, we need to protect the main part of your body. So I'm gonna stop doing what I need to do. That way, I can protect the main core. Is that kind of?
Well, essentially, I mean,
That
like
makes
it's not
sense.
just
Like a
it's not like
survival.
not as much where the cells are located as it is your body regenerates cells constantly, and so certain cells they'll die off, and then they need to recycle them, and this is all over the body. And autophagy is a process that is upregulated a lot when you're fasting. So when you're in a fasted state and you have this upregulation in autophagy, that allows your body to kind of clear all these damaged components, recycle these proteins so they can use them and make them into, newer, more effective proteins.
It's not doing that, or it is doing that.
Autophagy is that process. And when you are fasted, it increases that process. And so that is healthy. You want to go through this recycling of damaged proteins.
Oh.
Like you want that to be happening. Autophagy is a good thing. And a lot of the data show that increasing fasting upregulates autophagy and can help reduce some of these senescent cells, damaging proteins, and things like that. It's this, again, kind of like this clearing the streets and cleansing in a way.
Yeah.
And the problem is we don't really have any good metrics to measure autophagy. It's a very complex physiological process that involves a lot of different processes. And so there's not really a good way to measure it. There are some tools that certain labs will use, and these are effective in a way. But if you want to increase autophagy this significant level, you have to be fasted for a pretty long period of time. And that's why people have jumped to this like 3 to 7 day window, because it seems to be that autophagy isn't increased as much in those early 24 hours as it is 72 hours later.
Is this like a, so you're saying 7 day window of fasted, right? Do they then eat on day 8 and then do it again? Or is this like almost like a cleanse period?
So there's a lot of times these 7 day fasts are done like once a year, every or twice a year.
It's like,
and then people do 3 day fasts like every quarter year, and it depends. Everyone's going to approach it differently. And
yeah, I see a lot of people doing it after holidays because you're eating a lot and just kind of resets your system.
yeah,
That's kind of what I've seen through all the videos and research I've seen on Instagram.
Okay.
Yeah,
So it's like a cleanse in
that's
a way.
that's how people think of it. And
Okay.
my scientific molecular biology brain trying to explain something so simple as a cleanse.
I was just like,
yeah.
what?
So yeah, you're with me.
Well, okay.
Got you.
Yeah, I'm with you. Your body's doing a cleanse, clearing out the negative bullshit going on.
That's the idea. That's one of the ideas. There's multiple. And another idea, people are like, well, evolutionarily, we had to go look for our food, and
Have
then
you ever watched the show?
you eat a ton, and then you're fasting, and like they didn't do that intentionally. Our ancestors weren't like, I know you just
This is for our health.
and yeah, I know you just got that animal, but I'm going to have to wait because my feeding window's up at 6 hours. No, they're going to eat everything and anything, every opportunity they have. All that points to is you can eat whenever you want, essentially. Like the evolutionary ancestral claim is
Have you ever
bullshit.
seen the show Alone?
I haven't watched it, no.
I watched 1 or 2 episodes, yeah.
Yeah, it's where they like go into on like Vancouver Island.
Yep.
And they try and live off the land for, as long as they can.
Yeah, and the
They're
winner gets like $1 million, right?
Yeah, something like that.
Yeah.
Well, they're doing this, and they are losing hella weight, and they do not end up being healthy. Like, they have medical staff come in, and if they have reached a point where they're like, you're about to die, basically, because they're over and over again doing a fast, basically, trying to live off the land. And if they don't get food, well, that's just what it is. And they have to ration and basically do fasted for days on end, or have one meal a day of maybe a piece of fish or whatever. And you could just see from the beginning to the end, they do not look good.
Well, I mean, that's the problem is probably how they look in, what is it called? Alone. I was about to say Alive.
I think it's Alone.
I'm pretty sure it's Alone.
But
Yeah.
I mean, they're losing so much muscle, and that's the problem with this diet. I mean, like, if I wouldn't recommend fasting to anyone unless they had so much body fat to lose and had a ton of muscle already. So, because I don't care if you go longer than 16 hours of fasting, like, I don't care how much protein and resistance training you've done, you're going to hit that catabolic state. You're going to be breaking down muscle. You're not going to be healthy. So it's really hard on your body to go on these fasts. And there is Walter Longo. He's got a lab at UCLA. He's also out in Italy as well. If you watched the documentary with Zac Efron, what the heck is it called? It came out a couple years ago. Down to Earth with Zac Efron. Where he goes to different places and talks to people about being healthy. Well, he actually went and the guy in Italy, that's Walter Longo. He does a lot of research on fasting and came out with a paper studying what's called the fasting mimicking diet. He developed this because it's hard for people to fast for 7 days, but he believes in the health benefits so much that he started encouraging people to do a 5-day fasting mimicking diet where you start day 1 as 1,000 calories And then days 2 through 5 are 750 calories ish. And you're decreasing proteins and carbs and increasing fat during those time periods. And it mimics fasting enough to where they saw these health benefits in animal studies, especially. So they did a trial. This was in 2017. Had 100 participants go through a 5-day fasting mimicking diet versus a control for 3 months, and they did 5 days on the fasting diet, 25 days off. So it was 30-day cycles, and they went through 3 cycles. And they found that body fat, blood pressure, glucose levels, and a bunch of other markers of metabolic health improved. But it was really funny when you look into the paper, because I just want to see, okay, what about calorie restriction? I mean, you're fasting mimicking diet for 5 days. At the end, how many calories were they taking in? And they didn't measure it. They have this stupid quote. They say, similarly to the study in mice, we expected the fasting mimicking diet effects to be mostly independent of overall caloric intake. And so they're like, yeah, we just assumed they're not eating less calories. It's like, what? You got to measure that stuff if you're going to be making this claim. So I don't buy anything from the fasting mimicking diet stuff either, because they didn't address that. But when you get into fasting itself,
why do people make studies if they're not going to do it right?
Like follow through with it. Like,
it's hard.
I mean, I get you got to do study, you get this idea and you do your study, but I feel like you would take the steps to make sure it's
you put all
clearly
that work in, why
put
not do it
together
properly, right?
And
it's a lot of data, a lot of work, a lot of money, and it's hard. I mean, he's got a pretty big lab, though. I can imagine like taking some graduate student and being like, hey, your job is to assess caloric intake. They would have been happy. I don't know. It's tough, though, when you do these studies, and it's difficult to control for these things. It's easy for us to sit back and pick apart these studies, but they really are contributing to where we're at.
Picking them apart and not saying, hey, everybody, it works.
Yeah. Because I mean, it might. We'll see how it continues to play out, but we don't know the answer yet. So when you get into fasting, though, and seeing, is there this physiological benefit to not having calorie intake during a 24-plus hour period? The animal research, again, is pretty awesome. There's a cool study that came out of Wisconsin in 2022 where they had 4 different groups of mice for 16 weeks, and they wanted, because they know the calorie restriction has an influence. We know calorie restriction improves aspects of longevity and health span, lifespan. So they had 4 groups. One was the ad lib group, eat whatever it wants. The other group was ad lib, but it was diluted with this indigestible cellulose composition that resulted in only being able to absorb 70% of what they eat. So it was mimicking a 30% calorie reduction, but they could eat whenever they want still. And then they had your 3-day feeding window. So they gave mice 3 meals throughout the day at a 30% reduction. So same calorie restriction as that other group, but it was 3 meals per day. And that's to address, like the still being able to eat throughout the day. And mice will eat whatever. If you fast them and you throw food in there, they're going to eat everything. They'll even like hide food in their cages and stuff.
They're not going to be like, oh, I have a couple more
hours.
hours.
My fast is not up yet. And the 4th group, this was to the fasting group where they just gave them 1 meal a day at 30% reduction. And the mice ate that whole meal right away. So they were able to see, is it calorie restriction alone or is it fasting separate from calorie restriction? Is fasting having an independent effect? And they found that it did. Improvements in body composition, insulin sensitivity, certain genetic markers of aging, and all these processes were improved in the mice that not only were calorie restricted, but because they were on this 1 meal per day. There's another paper out of Texas that showed calorie restriction improved. This paper came out in 2022 as well. Calorie restriction improved longevity, and then when you decreased the feeding window to 2 hours, it improved it 30% more. So these animal studies are shaping out, but then let's look into the human studies, because that is what actually tells us what we know right now, right?
The story, yeah.
Well, that's yeah.
So there's a randomized controlled trial in 2021 that came out of the UK. They had 3 different groups. One group was 150% of their daily calorie intake. So they basically measured like what would a eucaloric diet be for these individuals. That's how many calories you're taking in to maintain body weight. You're not in a deficit, you're not in a surplus. And then they take 150% of those calories and have them eat every other day for 3 weeks. So they end up being, if you can picture this, 150%. So that's 50% more than you would eat in a typical day. You eat that one day, but then you fast the next day, and then you have 150, and then you fast, and then 150, yada, yada, yada for 3 weeks. That ends up equating to a 25% reduction in calorie intake, because over the span of these, is my math wrong? Did you say mm-mm? Oh, I was like, yeah, no. I was like, Joe, I got it right here. But also, like, I'm really bad at math, so
I
yeah.
can't do math that
No,
fast.
that adds up.
And then they had a similar calorie restriction, so 75% calorie restriction, but they ate, or 25%, sorry, 75% of their daily calorie intake, 25% restricted. They ate that every day, and then they had a 200% intake every other day. So that's your eucaloric group. They're getting the same amount of calories, but they're just splitting it into eating one day, taking another day off, eating another day. And the daily calorie restriction group lost almost all their weight as fat and preserved muscle mass, whereas the alternate day fasting group attenuated that loss in fat mass, and there was no difference in metabolic or cardiovascular outcomes. So they looked at gut hormones and these certain genes with metabolic function within the fat itself. They did a pretty extensive analysis here to show that there were no differences between the like every other day in terms of those aspects, but actually having the calorie restriction and doing it every day improved your ability to preserve lean mass and lost more body fat. So there wasn't this benefit that people were getting from this every other day. And then there's not a ton of studies on this, like the 3-day, 7-day. We don't have the research there because we don't like ethically know right now what that's going to do to people. And you're not going to get approved to study those things that actually might have quite a bit of a detriment to people's health. Because again, when you're going on those long fasts, you're moving, you're losing muscle. If you look back, these are a couple old studies, but they're pretty well controlled. So I want to bring them up. It's actually the same group that put out a paper in 2007. This lab was affiliated with the USDA out in Baltimore, and they first did a pilot study where they essentially just reduced meal frequency. They went from 3 meals per day to 1 meal per day, and the 1 meal was consumed between 4 and 8 p.m. versus 3 meals were scattered throughout. And they were eucaloric, so we're not in a deficit, so they matched calories. And they found that after 8 weeks, they did not have this improvement in any of these metabolic factors or anything with 3 meals per day.
Right?
Yeah,
that makes sense.
but also like people still seem to believe that this, having a fasting time period is going to improve this. Now they came out with an additional study where they did the same exact methodology, and it was kind of cool because the control or the participants were their own control subjects, where they had an 8-week time period where they ate 3 days per week or 3 times per day. And then they took an 11-week washout period. And then they were their own participant in the next arm of the study where they ate once per day.
Where they just...
So washout is go back to your daily habits for
Okay.
11 weeks. Let's get you back to where you can start a study in a different group where you eat once per day. So make sure everything comes back to baseline, like blood pressure, glucose, insulin, and stuff. And that's kind of a cool way to do these studies.
Yeah, but okay. Well, here's a thought behind that is after they do that study, are they actually going to go back to what they were, or are they going to think more healthy lifestyle and start eating better and then come back and they won't be the same?
People tend to kind of go back to their like habitual feeding. And that's showcased like in that You Are What You Eat documentary. Like no one is even able to maintain that. They didn't look at those types of things, but these tend to be pretty cool studies where physiologically, you're studying the same person on two separate diets over these time periods.
Right.
And yeah, the outcomes that they found when they looked at even a second time, they put out two papers. One was focused on like metabolic aspects and cardiovascular aspects. And they just found that one, there was no difference in certain things like blood pressure and cholesterol, but the one meal per day actually had an impaired insulin response to glucose. So they did what's called a glucose tolerance test, where they basically give you like 75 grams of glucose. It's disgusting, but it spikes your glucose up. And I talked about insulin being this chaperone that's like, whoa, 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 glucose is out. It's loose again. Let's make sure the liver and fat and muscle takes it all up. So insulin's rushing the streets, getting all that glucose. Yeah, it's like, yo, 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 glucose, go back to bed. Because you don't want that glucose running around your blood vessels. And so insulin's got to do its job. Now, people that are metabolically unhealthy, insulin's kind of lazy, like, let's just let the glucose go. And then,
a little bit.
yeah, well, yeah. But your
let's
pancreas
not think
that
so.
produces the glucose is like, no, go, insulin, get out there. And they're going to put out more and more insulin, but insulin's not really doing anything. It's just kind of floating around like, what's up, glucose? And do your thing. And so you get what's called insulin resistance. So your muscles, your liver, your fat is resistant to that insulin's effect being able to bring glucose and dispose of it. Having that one meal per day impaired the body's ability to dispose of glucose. It had this increased insulin resistance. And then they also found increased glucose levels throughout the day at fast and then also at night. Now, they did eat the diet later, so the increased glucose at night makes sense, but metabolically, these individuals were less healthy on this one meal per day. Again, this is a pretty old paper. We'll see how these things roll out. But, that's kind of where we're at with all this stuff. It's like there's still a lot of unknown, but it sure seems to be that, one, if you're going to go a time-restricted feeding diet, you don't want to step below 8 hours because you're losing lean mass. That's pretty clear. You're on such a caloric deficit that I worry you're not going to get the amount of protein that you need. So it's going to be really hard for you to hit that, target protein intake. So a lot of people going on time-restricted feeding.
And we don't want that.
Exactly. But 8-hour feeding windows, especially with resistance training, seem to provide this benefit in your ability to maintain muscle mass, but also still calorically restrict to the point where you're getting benefits. And then you look at the fasting data, and like this is just not. I used to be in the camp of like, okay, fasting is providing this benefit. And now as these papers keep coming out and the more we understand about it, like I'd be pretty hesitant to recommend intermittent fasting, whether it's one day, 72 hours or 1 week.
And intermittent fasting is not time restricted eating.
Right.
It's different.
It's different. I wouldn't recommend that to people.
Solidify that one.
Yeah. At first it's like, even if it isn't providing a benefit, it's not going to hurt you. Well, now it seems to be that it actually probably isn't healthy for you. It's actually probably detrimental to your health.
Well, your body starts looking for nutrition and what it needs to be active, and it just starts eating away at yourself.
Yeah, and if you want,
that's kind of, would that be the idea? It's like, it's going to eat my fat first?
Yeah, well, and then all this, this
mean?
Autophagy. That's what
like,
I hear the most about is this process of like cleanse. But you know what else increases autophagy?
Protein. Working out.
There we go. We did this in another. We did that in another episode, and you guys
I thought it was gonna be protein.
Yes,
but then I thought about Luke, and I was like, "It's got to be exercise,
like that one
dude."
time I was like, collagen.
No, there's.
You guys even listening to me?
I just said no.
Yeah.
Nope.
Yes, exercise increases autophagy. Also, calorie restriction increases autophagy itself. So, like, there's plenty of research on
calorie restriction. We're talking like 20%, 10%, 15%. What are we looking at for
a lot
healthy
of these
restriction?
A lot of these papers. So that Calorie study that I talked about in the calorie restriction,
That was 30, right?
they actually shot for 25% reduction in
Okay.
these individuals over a span of 2 years, but people weren't able to necessarily meet that. They fell short of that calorie intake, but still were restricted. So it seems to be like you can shoot for this 25% reduction, But whether it's like difficulty tracking calories and such, people tend to fall a little short of that. But that's kind of this number that tends to be studied a lot, is right around that 25 to sometimes even 30%. But you seem to get benefits even short of that too.
I always find it hard to find my calorie energy out number. Is it pretty solid when you do the calculation of your resting and then your active? When so let's
These,
say,
are you talking about like the online calculators if you put in
I
body
mean,
fat
just
and
like
stuff?
yeah, that's where I've found it, and it says 3,300 calories a day should be my goal for intake. I mean, yeah, I'm very active all day, and I do work out. So how accurate is that number? Is it pretty accurate, or should we be basing it off the 2,000 calorie diet?
So when you go on and try to get these estimates of calorie expenditure throughout the day, I mean, it's a ballpark estimate, and they tend to be a little bit far off because of the other aspects that you can't just know from somebody's
So like your
body.
body mass index needs to be taken into account.
Well, you also, so when you look at energy expenditure, it's not just your resting metabolic rate, that's easier to estimate from people, but your activity energy expenditure. So when you're out going doing exercise and at the gym, and then there's the NEAT, non-exercise adaptive non-exercise activity thermogenesis. So NEAT energy expenditure are things like, as you're fidgeting and doing things that aren't like intentional activity. That also increases energy expenditure. Some papers show like from 800 to 2,000 calories per day. People that fidget more tend to like burn more calories. It's crazy.
That's me.
Yeah.
And NEAT's
Yeah.
not just fidgeting, but yeah, I mean, like that comes into play. And then also this thermic effect of food. So increasing metabolic rate to break down certain, macronutrients you're taking in. Protein increases metabolic rate by increasing thermic effect of food. So the online things you fill out, sure, it gives you this ballpark, but in order to actually estimate it, a really good way is when you go in to do like a metabolic test, where we did these in the lab. You actually have people kind of just chill for like a half hour while you're measuring how much oxygen they're taking in and
RMA,
CO2.
that's what we did at lab.
Yeah, and so that's a really accurate way to get this
Okay.
resting metabolic rate, and then you
So
have
it
to
is.
really calculate all these other
Yeah.
aspects.
Anyway, that was just a little thought popped in the old brain.
So
So we can kind of throw all these benefits of fasting, because I looked on the Google machine and it's like improved overall fitness health from fasting, and like decreased metabolic disease, boost cognitive performance. Like, so is there any truth to that? Is that just kind of baloney? Because this is from Boulder Medical Center.
yeah, so when you look into the studies that they're referring to, you'll find these outcomes with fasting, and it's pretty impressive. But again, you look into the data and you see they're calorically restricted.
Yeah.
And so when you control for these things and you look into those studies that control, those are the ones that we just talked about, of like, you can't decipher this independent effect yet.
Yeah.
Like it seems pretty clear that the results that we're seeing are because they're calorie restricted, not because of this independent effect of fasting or time restricted feeding. So, but yeah, and I mean, that kind of gets at this whole idea of, if you have a hard time counting calories and trying to figure out how to get this 25% reduction, if that's your goal, try out a feeding window of 8 hours. Again, I wouldn't dip below that, because
I'd recommend it too.
yeah, then you're losing muscle, but try it out. You could even try, there's studies that use longer than 8 hour feeding windows. Like a 10-hour feeding window might be a little bit easier. And, the only thing that I'm curious about as we see more research come out is waiting to eat in the morning. I just wouldn't want to mess around with this catabolic state that we're in after our overnight fast and missing out on protein intake. And
your window of being catabolic or becoming catabolic is up to what? Like, I think it was was it 12 or 15 hours after?
You're thinking anabolic window after exercise.
Yeah, but
and
like
protein
before
intake.
you become catabolic is. So I said it that way, but different.
Yeah, I don't know that we know the exact like time frame of it because everyone's going to be a little bit different with that. But here's what I would say: if you're doing a fast, time restricted feeding wise, it's going to be to try to get this level of calorie restriction, or at least it should be, because that's where we're at with the data. I wouldn't worry about, you can wake up, take your protein shake in the morning, and I wouldn't count that as breaking your fast. You're trying to be calorically restricted from things like high glucose intake, high fat intake. Having this protein in the morning is not going to impair your calorie intake over the course of the day. So that's how I would do it. Okay, maybe if I did an 8-hour feeding window, I would still have a protein shake in the morning. I wouldn't worry about that.
Get some sort of substance to
break that fast and get back in this anabolic stage. You just, muscle's so great, you don't want to lose it.
Yeah, it keeps you going, keeps you moving.
All right, Luke, who's going to be the winner between calorie restriction and fasting?
Woo! All right. You ready? Are you ready?
I think I know this one.
All right.
I mean,
based on where we're at, and I assume you can kind of tell by the end of this, calorie restriction takes the cake on this.
Yeah,
and it all comes down to...
I mean, you said calorie restriction so many times that I forgot what side of the table we were on. So, yeah. Go ahead and say what you're going to say. Sorry.
Yeah, I mean, but so calorie restriction definitely wins. Now, you can utilize time-restricted feeding to get to calorie restriction. So it's still a useful tool, but yeah, we're taking calorie restriction with the dub on this one.
The dub.
Yeah. I think that sounds good.
You guys would agree?
I definitely would
yeah,
not
definitely.
do the fasting.
What did you guys think coming in before we did the calorie restriction episode?
Calorie restriction.
You still did?
Well, I was also confused because I thought intermittent fasting was...
Time restricted eating.
Yeah.
That's what I always get mixed up to.
Yeah. And I mean, and that's why we grouped them together, is because everyone does mix them up. But I did want to decipher, like break them apart. So we could talk about the science.
So I was thinking intermittent fasting, but in the sense of like a feeding window.
Mm-hmm. So you were thinking time restricted feeding better than calorie restriction.
Yeah, I guess I was.
Okay. And you read?
But not one meal a day.
Yeah, time restricted feeding was your...
Yeah.
Yeah.
Am I confusing it again? I think I...
No. I'm confusing you guys by splitting these. Essentially, you're saying the time restricted feeding diet was better than calorie restriction in your opinion.
Yeah, but
beforehand.
I guess it goes hand in hand, because in a window of feeding, it's going to be tough to get your entire caloric intake that you're shooting for.
Yeah. I'm saying before I said anything, like just what was your thought coming in?
Time restricted.
Time restricted eating. Sorry.
I'm saying it's worked for me for 10 plus years, but
yeah.
I just need that next step. So I really want to track my calories. So I think doing both will just really get me to that next step where I want to be.
So I changed both your minds. I love science.
That's great.
Well, I didn't change your minds. The data changed your minds.
Science did. You just explained it.
Yeah.
And I understand it. But no, I don't think I would. I guess I wouldn't do it either way now. Not right now, because I just changed my diet again. I'm eating in the morning.
After the protein episode?
Yeah.
Yeah, the protein really changed everything.
Well, it's tough to get all that protein in that. Well, I guess you could if you really wanted to, but
I'd say just like I was saying before, get your protein outside of that feeding window. Don't worry about like this circadian
Well, and I don't want
aspect.
to get into a catabolic state either. Now, like that we talked about protein.
Yeah.
Right. Was that the one we did? Catabolic?
Yep.
Yeah.
Mm-hmm.
So I think that put me in a place where I'm like, all right, well, it makes sense to eat throughout the day, keep myself anabolic. You're always burning when you're getting that protein. You're what is it? The thermo effect of the food.
Thermic effect.
Thermic effect of the food is burning calories, which is something I didn't know that protein did. So I don't know. Yeah, you did change my mind, but not enough to do it.
Do we have to be done? I'm gonna miss you guys.
I know. Yeah. Got to wrap this up.
Do we?
Yeah. We've already hit about an hour, 30 minutes here.
No way.
We just kept going.
We might have to split it up.
Nah, it'll be good.
People, if you have any questions or comments or
Concerns,
anything you
insults?
want to know, Luke will answer those questions in the comments.
Yeah, you don't want us answering.
Yeah, let us know what you think. Let us know who you would have picked and all that.
Yeah.
Love hearing from you.
Cool. Good job, guys. That was
Thanks
fun.
again
Thanks for
for
listening,
tuning
everybody.
in to the Kickback Science Podcast. We love talking science with all of you, and if you feel the same, you can support us by subscribing, hitting that like button, and giving us a follow on our social media pages. Don't forget, you can submit questions through our website and in the comments section of all our social media. Have a good one, everyone.